Hi there, Glenn Mitchell here. I've got a new series of video tutorials on layer blending modes. The ability to use blending modes is one of those skills that separates the intermediate Photoshop user from the beginner, because we can use the blending modes to create some important photographic effects. We can use it to lighten images, darken images, do dodge and burn effects, etc. Blending modes allow us to knit together the tonal and color information from two or more layers. There'll be one video for each of the different layer blending modes in Photoshop so that we can focus on each one in turn. We're going to get started with a normal blend, because normal is the default blend mode in Photoshop. With a normal blend, every pixel in the active layer is blended normally. That's a nice circular definition. What do I mean by being blended normally? That means that the tonal and color values of the visible layers underneath are basically ignored. We're not using them to determine how to blend the two together. At 100% opacity, the tonal and color values for the layers underneath are invisible. The layer is totally opaque, and all we see is the active layer. Anything underneath is ignored. At 0% opacity, the active layer is 100% transparent. It's completely ignored, and all we see is what's underneath. In between values for opacity, average the two values together. There are some simple mathematical formulas behind the different blending modes, and I'd like to take a few moments in each video and talk about them. Now, I know for some of you, talking about mathematics is going to make your head hurt. Feel free to skip past that if you want to. You can hit the fast forward button, but I promise to keep the math simple. We're talking addition, subtraction, multiplication, division. We're not talking advanced mathematics here. The formulas I'll be giving you apply to an RGB or a CMYK image. If we talk about some other color space like lab color space, things can get squirrely. The formulas change. But since we're talking about digital photography here, most digital photographers deal with images that are in RGB or CMYK. I've seen a lot of videos and read a lot of tutorials on blending modes. Most of them will tell you that when layers are blended together, it's done pixel by pixel and channel by channel. Well, they're right. Blending is done pixel by pixel. Photoshop looks at the pixel value in the active layer, and it compares it with what's visible underneath, and then some kind of operation is performed. It's not 100% true that it's always done channel by channel. That's usually the case. That's almost always the case. But there are a couple of exceptions, and so we will talk about them when we get to the layer blend modes where that's not always the case. The other thing about layer modes is that sometimes the order of the layers matters. If we switch them around, we get a different visible effect. But we'll talk about it in each case. We'll talk about what happens if we were to switch the layers around. So let's take a look at the sample image here, and let's talk about the normal blend mode. The sample image that I'm using in this video is a composite of two photographs, and then I've added a layer on top that we'll be using throughout this video series to show the effect of different blend modes. If you look at the layer palette here, it's pretty obvious what's going on. The target has a gradient here on the left that goes from black to white. In the middle, there's this graphic design, this X shape. Far corners here, 25% gray patches. Far corners here, 75% gray patches. Around the center, 100% gray patches. And right in the middle, a 75% gray patch. We'll find that with different layer blend modes, we can get some very profound differences here. To illustrate this, let's just change quickly from a normal mode to overlay mode, and that's a very profound difference. We're here to talk about the normal mode. With a normal blend, an opacity of 50% simply averages the pixels in the active layer with what's visible underneath. It's just a plain, simple average. Take the two values and divide by 2. Works just like a baseball score. Look at a given pixel, get the value for one of the channels. As an example, let's say in our active layer, the value is 200. In the layer underneath, what's visible underneath for the same pixel, same channel, is 100. All we have to do is add 200 plus 100. That's 300. Divide by 2, and we get a value of 150. Do that for each pixel, for each of its channels, and that's what we get with 50% opacity. At 100% opacity, all we get is the value of the active layer. At 0% opacity, All we get is what's visible underneath. Really what's going on is what we call a weighted average. It just happens that at 50% it's a nice simple average. But if we want to be general about it and we want to talk about what happens, whether we're talking about 100% opacity, 0% opacity, 50%, 5%, 95%, whatever it is, it's a pretty simple formula. Let's talk briefly about the math behind the opacity setting. The math involves two numbers. Let's pretend that we're looking at a single pixel and at one channel from that pixel, maybe the red channel since we're talking about RGB. Active is the value for the active layer, whichever layer it is that we have active at the moment. Underlying is the value of what's visible underneath that layer. Then the blended value is simply the active layer's value times the opacity, and then we add on to that the underlying value, and we subtract the opacity from 1. For the math to work easily, we need to convert the opacity from 0 to 100 to 0 to 1, and we simply do that by dividing it by 100. So in the example that I've already mentioned before, if we start off with the active layer being at 200 and our opacity set at 90%, then for the underlying layer, we're taking 10% of the information from that. We're getting 90% from the active layer. We must be then getting 10% from the underlying layer. And so you can see in the formula down here, it's 200 times 0.9, and then we add 100, the value of our underlying layer, times 0.1. And that translates into 180, because that's what 200 times 0.9 equals, plus 10, which is what 100 times 0.1 equals, and that gives us a pixel value of 190. Another way to think of it, we took 90% of the difference between the active value and the underlying value, and we added it on to the underlying value. So the difference between 200 and 100 is 100. If we took 90% of that, just multiply it by 0.9, we would add on 90 to our underlying value. 100 plus 90, again, brings us to 190. Changing the opacity for the active layer can have a very visible effect on the photograph. For example, if we raise the opacity here from 50% to 75%, the test target will dominate the photograph. If we reduce it down to something more like 25%, it'll be much less noticeable. Now, I'll grant you that the normal blending mode is not the sexiest of the blending modes. There's not a lot of excitement around the normal blending mode. You'll find, however, that you use it a lot, especially with adjustment layers. Those kinds of layers where you're applying levels or you're applying curves, because the whole idea is we just want to be able to attenuate the effect. We want to be able to reduce it. So we'll go ahead, we'll apply a curve that has a really big impact on the photograph, and then we'll tame it by reducing the opacity. So even though it's not very sexy, the normal blend is the workhorse for blending together layers in Photoshop. I'm Glenn Mitchell from thelightsright.com. Cheers.